What are the causes of human error? The news is filled with accidents these days. Airline crashes, bridge collapses, chemical fires, explosions. Sometimes it feels like there's a new disaster every day. One of the things you can be sure of in all of the accidents above, someone screwed up. You never have a major accident if all the safeguards function as designed. And guess what? We depend on human actions in many cases as significant or sometimes the only safeguard. This means that human error is directly linked to major accidents. And that's all we hear on the news. Human error, somebody made a mistake. In this webinar, we're going to discuss the different ways people make mistakes, some of the methods to identify them, and most importantly, what you should do when you find human error in your investigations. Now, I want to start off with a simple model. This is from James Reason, and it's his accident model. And in this model, you can see we have a hazard, we have targets, and we have failed defenses. And an incident occurs when a hazard breaks through those defenses and comes in contact with a target. Now, Reason believed that there were different types of errors that allowed these defenses to fail. He had two types. He had active errors and latent conditions. He later broke those active errors into three different types of active errors. Now, these are kind of our definitions of those, but you have slips, lapses, and mistakes. The active error of a slip is when somebody was trying to do the right thing, but they goofed up. They made an active error. They made some sort of small mistake. You also have lapses when someone would have done the right thing, but they just forgot. It's kind of a memory error. Oops, it slipped my mind. And then you have mistakes. This is when somebody makes a mistake when following a rule. Maybe that's unintentional or intentional, maybe like a violation. So anytime somebody breaks a rule, that would kind of fall in the mistake. That's kind of the active errors portion of this. We also have latent errors. Now, a latent error is a system-based problem that lie in wait to trap you. Originally, this came out of the medical industry when they kind of thought of like latent conditions, right? You might have had a parasite that was laying dormant in you and something caused it to activate and start to grow. So they have these conditions waiting for the right moment that come in and cause problems. Now, mostly Reason created this model to help psychologists understand and categorize human error. It wasn't a diagnostic. It wasn't something that was used to fix errors, but just categorize what was happening. Now, you can kind of see that psychologists' views on human errors were a little bit more on the academic side. It was about how do we categorize. This doesn't mean it was particularly helpful in helping people analyze it for a industrial or medical application and figuring out how to actually solve those problems. It really just stated these are the types of errors that might occur. And Reason himself said there's no good way of classifying errors, but you try to find a way that can show you how to take remedial action. So when we think about models of errors, we want to think about how does that model help us fix problems? How does it give people an understanding of what mistakes are being made and give us guidance on ideas for how to fix it? So let's take a look at a model that helps us think about this and understand from a system perspective what we need to be looking at. Now let's look at this model and see what is a hazard. A hazard is a source of energy. That can be potential energy that's converted. It can be things like gravity, motion, electrical hazards, anywhere that we have sources of energy that can cause harm. We have a target, that's the thing we're trying to protect. It could be people, environment, equipment, and you have these safeguards. Those are the controls that we have on that energy that protect that hazard from the target. Now, when that hazard comes in contact with the target, the worst consequence of that is the incident. And when we're doing investigations, we need to look for the errors that allowed those safeguards to fail. You have to understand the mistakes and errors that allow those safeguards to go missing and identify how they are affecting those safeguards. Once you understand the mistake, then you can use a technique like TapRooT to help you analyze the human error for root cause. Now, we're not going to focus on root cause analysis in today's webinar. We'll provide some resources at the end that can help you look at that. But we need to understand how people make mistakes so that we can understand how to analyze them later. Now, the first step in understanding how accidents happen is to recognize that this model is simplified. Something important that we mentioned before, major accidents happen when all safeguards fail. So realistically, having a single safeguard is not the most realistic. You can imagine this as multiple layers of defense. Reason like to use what we call the Swiss cheese model. So you can see instead of one failed brick wall, we've got multiple failed safeguards in a system. So as we look at the system, we want to look at the different points at which failure might occur. The other thing we need to look at is how does human error impact these different elements, these different failed safeguards? We could have errors that allowed a hazard to exist or to be too large. You could also have errors that allow a safeguard to fail, meaning we violated that safeguard. You could also have errors that allowed safeguards to be missing, errors that allowed a hazard to be too close to a target, and errors allowing an incident to become worse after the hazard comes in contact. And this idea of multiple failure points gives us a new way to look at human error. This model allows us to look at how error can affect those different elements. By classifying error by how it impacts the hazard, target, and safeguards, we can better understand what we're trying to fix. So let's look at this example. Let's say we have a chemical, a hazardous chemical that we want to keep control of. So we'll put that chemical in a barrel and put it in a safe storage location. Now we have to purchase this chemical and our supply chain orders too much. They made a mistake. They put a fat finger in there and put an extra 0 in the quantity. So now we've got 10 times the material that we needed. And we have to figure out how to deal with this. So you had a mistake that allows a hazard to exist or be too large. We've got too much of this chemical. Well, that would be fine, but there was an error that allowed the hazard to be too close to the target. We didn't have the storage space for this chemical, so we had to store it next to the aisleway. But it's a busy trafficked aisleway. We've got fork trucks and people moving around this area a lot. So now it's too close to a hazard. Well, that's okay because we have guardrails that would prevent anybody from hitting this. But maintenance was working in the area, and so they had to remove the guardrail so they could do work, and they hadn't put it back in place yet. Again, we can see errors that allow safeguards to go missing from our system. But we've got this barrel, it's protecting that chemical until one day a forklift comes along and has to dodge a person that's in the aisleway, and they run into that barrel and they puncture it, causing chemical to spray. That's a failed safeguard, puncturing that barrel, causing chemical to spray all over the employee. Now this is a problem, but luckily we've got safety showers all over the facility and the employee runs to that. Well, there could be errors or equipment failures, and now when they go to pull that shower, it doesn't work. And the employee is now having to run to a bathroom and wash off in a sink trying to get this chemical off their skin. So looking at these different ways that your system is breaking down, that can lead to better understanding how to fix those problems in your system. Now, the problem with Reason's model, we talked about what was its purpose. Well, it was focused on helping academics. And a lot of these models that we're talking about are not as easy or helpful to people. Just because I can explain in a diagram how these safeguards failed doesn't mean that it's easy for investigators to understand that failure. Most investigators, they don't care about psychological terms. Getting technical like that doesn't help them understand their system breakdowns. So here at TapRooT, we found the need to simplify what we're looking for when it comes to causal factors. Now, I want to give you the definition of a causal factor. A causal factor is a mistake, error, or equipment failure that directly leads to an incident or makes the outcome of the incident worse. This helps us think about what types of problems we're looking for. It could be human errors, but it could also be equipment difficulties and equipment not working right. Now, when looking for causal factors, we're looking for actions or a lack of action in the incident timeline. And there are 5 types of causal factors to look for. The first, I think, is the easiest to find. Looking for equipment failures. Now, your equipment can break down for a number of reasons. It can break down because of equipment difficulties like different maintenance parts, supplied materials, and all sorts of things can cause equipment to break down. But there's also human actions that lead to it. Maybe it's being not properly maintained. Maybe there are issues with how people are using it and abusing that equipment. So we want to identify where in our system did our equipment break down, and that's going to help us better understand those different equipment failures. The second type of causal factors to look for is an incorrect action. Now, people break rules, just like Reason said. They make mistakes and they break rules. Some of these are intentional violations, but others are unintentional. No one intends to fall off of a scaffolding or fall through a roof. But those actions do occur, and they can often be caused by intentional violations, but things like the environmental conditions as well. So we want to look at where mistakes, incorrect actions are being made. The third type allows us to look at both how we respond and opportunities. So the third type of causal factor to look for is a missed catch. Where in our process should we have caught that equipment failure or incorrect action? How could we have caught that mistake and prevented it from leading to the incident? Oftentimes, parts of our system fail to catch mistakes that were made earlier in the process. And we want to identify those opportunities as well. The fourth type of causal factor to look for is violated safeguards. This can be things where people are not wearing PPE, maybe they're not following practices like lockout, tagout. There's lots of safeguards that we have inherent in our system, and those safeguards can be violated, removed, bypassed. When you look at the hierarchy of controls, oftentimes people say PPE is the weakest in the hierarchy of controls. However, when you think about safeguards and effectiveness of safeguards, there is not a safeguard out there that doesn't rely on people in some capacity to maintain it and operate it. Whether we're talking engineering controls that we have to make sure that we're doing PMs on and audits to verify they're still in place, or if we're talking simple things like wearing PPE. Again, you've got to have humans maintaining your management systems, auditing, making sure that they're working or still in place. It doesn't matter if it's a physical barrier or if it is a human or administrative control. So look for those violated safeguards. The fifth type of causal factor to look for is actions that made the outcome worse. The way that people respond to errors can make an accident have a worse outcome. Again, I think of an example of somebody that opens the wrong valve or starts working on the wrong line. Maybe they locked and tagged out this line, but they started working on a different one. Suddenly they get sprayed. And there's this panic moment, and a person responds by trying to lock it down. They stay in the spray, and that creates a worse outcome for the person. If, when they had made the mistake, they had moved away, the outcome of the incident might have been less severe. Maybe they wouldn't have got as burned as much. Maybe the impact on the person would have been lessened. So we need to look at how people respond and how their actions, do they make the outcome worse or better? And look for those opportunities to affect the chain of events in an incident. So those are the 5 types of causal factors: equipment failures, incorrect actions, missed catches, violated safeguards, and mistakes that made the outcome worse. Now, it's extremely important that you understand just because we found human error does not mean we are done with our investigations. So many investigations find that people make a mistake and they stop right there, blame the person, and focus on discipline and not looking at the underlying system causes that allowed a person to make a mistake. So this process of looking for error is just the starting point of understanding what happened in an incident and what mistakes led to that incident. You don't want to start with human error and end with human error. You want to start to gather and understand the context behind that error. Now, you can check out this earlier video that I did on how human error is not a root cause to further explore this topic. So, is human error always to blame? Well, certainly humans are going to make mistakes. To err is human after all. But blame teaches us nothing. By focusing on blaming the individual, you're going to be missing opportunities. We need to understand how mistakes happen and focus on our system. The real question is not, are humans always to blame, but what are you going to do when you find a person made a mistake? Are you going to stop and discipline that person, hoping to never see the same mistake twice? Or are you going to dig deeper and see how the system set them up for success and failure? As I've said, there's lots of resources that you can use to better understand human error. Check out a few of our videos when we talk about blame and human error. Go look at the links below where you can go to the TapRooT website and check out our TapRooT courses to help you better understand how to find error in investigations and, more importantly, how to uncover the system problems that are leading to people making mistakes. So thanks for attending our webinar. Check out the resources below, and I hope to see you at a TapRooT class in the future.